Okay. We have a original coordinate. Where will it go? So this is an A, and that's a B. So you always are recognizing the letters. So I'm going to do this. X would get divided by a half, and AY. Remember when I said fill out that math coordinate? I'm always going back to this. I'm always going back to that. So I divided the B and I times the A there. Okay, are you okay if I change the looks of that fraction? So what would be the math concept of dividing by 1/2? Same as timesing by 2. Okay, so let's change 16,4. It's going to now become 32. So obviously it horizontally got stretched. Comma, what's 1/4 of 4? 1. It got vertically compressed by 4. Okay. This is a or B? An A. So that changes the X or the Y? The Y. So that's what I would do. That's where the A goes. So my new coordinate would be 8, positive 24. Okay, A, B, C, D. So this one is the B position. So when I write my coordinate, X would get divided. So now, what does that point become? So 8 would now change to -8, and nothing happens with your Y. I get sometimes people getting confused and all of a sudden 2 things are changing. Nope, just one of them is changing. Okay, the last one here. Oh, what am I doing? C and E there. I have an A, a C, and a D. So what is your coordinate? Okay, don't just figure out the coordinate. Right. X would get -3. AY plus D. So AY plus D. Okay, you're always seeing how I'm fitting that back into that coordinate. Okay, so if you had an 8, 8 minus 3 is 5. Okay, be careful here. What is the negative of -24? Positive 24 plus 2. Okay, grade 11. Let's graph y equals x squared. You remember how to graph just a parabola? What's your normal parabola look like? 0, 0? What's another point on a parabola? Just the normal parabola. 1, 1 is on a parabola. 2, 4. 3, 9. Can you flip-flop those points to the other side as well? Why am I all lopsided here? This one.
Yeah.
Like, that doesn't look very symmetrical. There. Okay. There's my normal. So this is a A. This is a C. And this is a D. So the coordinates would get changed. X, what are you going to write? Did you do a +4? That's the only change on the X. And you got an A and a D, so 3y plus 2. Okay, I have the coordinates here. So those are the coordinates that we drew. You don't have to necessarily take all of them because you're probably just going to see a pattern, right? But okay, I'm going to give you my trick because I like to do things as fast as possible. So I'm going to show you how I do it that makes it a little bit faster. I'm going to run all my x's through. So all of them will get added by 4. So this -3 will be 1, 2, 3, 4, 5, 6, 7. So I ran all my x's through. So I added 4 to all the x's. So that just makes me a little bit faster. I don't have to rethink about that every time. I'm just going to go, let's do them all. Okay, now I'll run all the y's through. 3 times 9, 27, plus 2 is 29. Probably not going to graph that. What's that? I'm probably not going to graph that one. Okay, 3 times 4, 12, so 14. 3 times 1 plus 2, do you get to a 5? 3 times 0, 0. Plus 2 is 2. Hey, isn't this going to be symmetric here? 5, 14, 29. Right? Because of the, those are both 1s, those are both 4s. Okay, so can you graph, I don't know, 3, 5, 4, 2, 5, 5. Ooh, I kind of would like that 14 on there, but I'm going to kind of draw a 14. That's going to make it up, but okay, so here's what we're going to talk about. -4, do you see some kind of right 4 movement? Do you visually see it? Do you see some kind of up 2 movement? Vertically stretching by 3. So here's what I want you to look at when you're looking at this. What's the distance between those points? They're only spaced out 1 apart. Now, what's the spacing between the points? 3. What's the vertical spacing between those points? 4. Now, what's the vertical spacing between those points? 12. So do you see what's happening? It's pulling the points apart from each other. Okay, let's try another one. So this is the graph of y equals the square root of x. You're going to learn that next unit, how to graph them. So I did it for you. Now you're going to do the graph of y equals the square root of 2x. Okay, so let's take some coordinates. So 0, 0 is a coordinate. 1, 1 is a coordinate. Where do you see a next coordinate? 4, 2. Does anybody want to predict the next coordinate? 9, 3. Okay, we're going to transform these points. Oh, which letter is that? The 2 is a B, C, or D? A B. Okay, so x divided by 2, comma y. So I'm going to run all of my x's through. I'm going to do that because it makes me a little bit faster. So I have to cut them in half. So 0, 0.5, 2, and then 4.5. So I took half to all those, and nothing will change on my y's. So here's my new coordinates. Let's graph it and see what happens. So 0, 0, a half, comma 1, 2, 2, 4.5, comma 3. Okay, so do you physically see this? From there to there, they were spaced out 4 apart, and now they are spaced out 2 apart. Because what is physically happening on this graph? If there's a B of 2, what will physically happen? Your accordion, you're going to horizontally compress by 2. Okay, last one. If I give you any random graph, you better just pick some points, any points you want. So I probably suggest taking the coordinate -4, 0. What would be a next good coordinate to take? Probably 0, -2. I'm probably going to take 1, 0. And I think I would like to do 2, 2, right at the arrowhead. Okay, so I took a sample of points to get a pattern. Okay, graph number 1, what do you have for letters? You have a C and a D. So what is your formula going to have in it? Your equation will have to go x plus 2, opposite, and you're going to have to do a y plus 3. Okay, ready? Put all the x's through. That's the fastest way to do it. Say add 2 to every x. And then go through all the y's and add 3. Okay, so those are my 4 new coordinates. Can you connect the shape like it's supposed to be? Can you make sure somewhere there's probably going to be a discontinued, like a stop point, and somewhere there's going to be an arrowhead, right? So that's the shape. All I did was I kind of picked it up and I moved it right and up. I just like grabbed it off the paper and I moved it right and up. Okay, number 2 has an A and a B. So I'm going to be doing x divide by 2, 3y. Let's take all the x's. Divide all the x's by 2. And take all the y's through there and times them by 3. Okay, ask yourself if you're visually seeing things that you're supposed to see. Do you see that your points got vertically pulled apart? Do you see it? Do you see that I took my accordion and I squished them in together? Okay, do you see that in your shape? All right, last one. This is an A. So that means x comma negative y. So don't change anything to those x values. And then change all the y values to negative. So, well, 0 just stays 0. Okay, so when you're connecting that, where does the arrow go? Think about that reflection piece. Do you see the arrow where it would go? Now my arrow will be heading downward because it reflected. Okay, I'm going to just talk quickly about something here and then let you go. Okay. If I have an A, that's what it looks like, right? If I have a B, this is what it looks like. Okay? Do you understand this is what it's doing? It's negating the entire function. What is this doing? It's negating just the x. Okay? It's a different concept. So, if I have a function that is this, do you guys know what that looks like? It's a parabola. That's what it is. It's a parabola. It's shifted up 4. Okay? If I wanted to do an A, I would have to negate the whole function. That's what it would look like, which would in turn do that, right? Because if I negated the whole function, which makes sense because what do you know about this? Now it's a -4 heading down. Okay? Do you see why I would be wrong if I just negated the x squared? This is what it would do. Did that reflect over the x-axis? No. It reflected, but it didn't reflect over the axis. So that's why I'd be wrong. Okay? Now, if I wanted to do a b, I would negate just the x part in the function. That's what I would do. So do you see the difference? This is an a where I negated the whole thing, and this is a b where I negated just the x. Okay, make your connections. This actually just turns out to be the same thing, because what happens when you reflect that over the y-axis? It wouldn't change. Okay, that being said, there's just two things in your notes here. So, looking at this, do you see me doing different things here? What do you think I was doing here? Looks like I'm negating every x. So if I'm negating just the x's, is it an a or a b number that I'm affecting? If I'm negating the x's, what is it? It's a b. So it's a reflection over the y-axis. Then here, do you see what I did in notation? I negated the entire function. So if you negate in the front of the function, then it's a, which would reflect over the x-axis. Okay, now here, do you see what I did? Every time I saw an x, I subtracted 2. I saw an x, I subtracted 2. So I'm applying it to each x I see. So which A, B, C, or D is happening in that? Every time I see an x, I'm doing a subtract 2 with it. So which letter am I using? A, the B, the C, or the D? I'm using a C. Because every time I see an x, subtract 2 with it. Subtract 2 with it in brackets. So this would be moving a shift which way? Right. Now, so there was a subtract 2 in that. This also has a subtract 2, but I just had the function subtract 2. So which letter would I be doing in that one? The function minus 2. So that means I put a D into it, which means it will move down 2. Okay, so on page 6, you're going to run into some format like that. So think about, is it applying to the whole function, or is it applying to the x part of the function? That will tell you the difference between A or